The next set of questions over here are again little comparisons, but let's start with the first one here. Which of the following is a solid at RT, room temperature? That's my little shorthand for you. So which of the following is a solid at RT? So when you're looking for something solid, it means that it has higher intermolecular forces. So really, let's go ahead and just look at all the intermolecular forces present in all of these. So this is C6H5COOH. So as soon as I see the OH, I know that I have hydrogen bonding. If there is another extra O in there, that means I have dipole forces. I'll draw the structure out here for you so that you can get an idea also what it looks like. This is what it is. So here's the hydrogen bonding and here is the dipole forces. And again, you know that OH also has some dipole forces, okay? But it's more like hydrogen bonding if you're just looking at itself. Then here we have CH3, CH2, 8, which means there are 8 of the CH2s and CH3. So there is no electronegative element in this, so I would go for dispersion forces for this one. C6H4, again all carbon and hydrogen. So again, I have only dispersion forces in this one. The next one is CH3, CH2, 2O, and this is kind of what we just did in the previous problems. This is what this is. And so yeah, there is a dipole moment over here going on. So which means that this has dipole forces. So comparing all the different forces, intermolecular forces, we can see that the first one, C6H5COOH, that has the highest intermolecular forces. So it's more likely that this is going to be the solid. And let's just go ahead and arrange all of these anyway in order of intermolecular forces. The next one will be then CH3, CH2, 2O, because that has dipole forces. The next one will be the CH3, CH2, 8, because here I have 10 carbons. So 10 carbons meaning higher molecular weight. Here in the C6H14, I have only 6 carbons. Okay, so which means I have a lower molecular weight. So which means that the CH3, CH2, 8, CH3, this will have higher dispersion forces than C6H14. So that is my order of intermolecular forces. Okay, and so it's more likely that this is a solid and maybe C6H14 is a liquid. Okay, we don't know what are these two in the middle. Most likely this one is a liquid, this is liquid, this is liquid, this is liquid, this is the only one that is solid. Okay, number 2, which has a higher surface tension. Surface tension also has to do with intermolecular forces. Again, higher intermolecular forces, higher surface tension. So looking at H2O, CH3, CH3, this one has hydrogen bonding and this one has only dispersion forces. So which means that H2O is going to have higher surface tension. C4H9OH, again we have H bonding. CH3O, CH3, this one has dipole interaction, and so H bonding rules, and so this one is going to have a higher surface tension, hydrogen bonding. Next question, which has a higher vapor pressure? Vapor pressure meaning that you have molecules that are escaping. The only way molecules will escape is when they have lower intermolecular forces. So this question really is about lower IM forces, not higher. Okay, previously with the solid and the surface tension, it was higher intermolecular forces. Here the question is asking you which one is lower in intermolecular forces, because that is the compound that is going to have a higher vapor pressure. So the first one here, CH3, CH2, 4, CH3, or CH3, CH2O, CH2, CH3. And then clearly you can see that I have only dispersion forces here, whereas in this compound where I have oxygen, and I've drawn the structure several times, so hopefully you can see it over here also. But this one is going to have dipole interaction. So if this has dipole interactions, This one should have a higher vapor pressure because this one has only dispersion forces. So therefore lower intermolecular forces, and that's what we're looking for, okay, for this one. All right, in the next case where we have CH3OH or NaOH. So CH3OH, this is a covalent compound, whereas NaOH is actually an ionic compound. So in an ionic compound, the forces that you have are what we call electrostatic forces. And electrostatic forces, as you know, are very, very strong. Okay, so covalent compound here, even though I have hydrogen bonding, hydrogen bonding has nothing over electrostatic forces. Okay, so which means that hydrogen bonding here is weaker IM force, and because this is weaker, this is going to have a higher vapor pressure. Okay, again, remember you're looking for lower intermolecular forces for higher vapor pressure.